Math 1, Practice 2.2.1, Solving Linear Inequalities in Two Variables. So essentially we're taking these inequalities, because they have two variables, and we're graphing them on a coordinate plane. Now, a few things to do this. First step, okay, is we treat this like it were an equation. Y equals 2x. Okay. So what would be the y-intercept? Well, there's no plus number, so it would be plus 0. So our y-intercept's right here. We do, however, have the slope, so it's like 2 over 1. So we go up 2 to the right one, up 2 to the right one, or down 2 to the left one. Okay. So we draw our points. And down 2 to the left one. Okay. Now, we don't draw our line yet, because there's two things to think about. If you have greater than or less than, the line is actually going to be dashed or dotted, because the line is not part of the answer. Okay? It's a boundary, but it's not part of it. So this one has no equal to, so it would be a dashed line. Okay? That's the first thing. Now, if it were greater than or equal to or less than or equal to, you draw a solid line. Okay? So first step, turn it into an equation and graph, but don't draw the line. Second step, look back at your inequality, decide if it's dashed or solid. Then the third step is, which side are we going to shade on? Because an inequality represents more than one answer. It represents a zone of answers. Okay? The best way to do this is to pick a point. A point not on the line, anywhere. Let's pick this point right here. This point is 2, 0. An x value of 2, a y value of 0. Take your inequality and replace the y value with your y value, 0. Greater than 2 times x value, 2. And then simplify. 0. 2 times 2 is 4. And then ask, is 0 greater than 4? The answer obviously is no. That means this part isn't an answer. So you cannot shade that side, because that's not part of your answer. Okay, if you want me to show you what I mean, what if we did negative 2, 0? If we picked a point on this half of the graph, okay, because we picked a point on the right side and it didn't work, it tells us this whole right side is bad. It's not your answer. So you should shade over here. And you would shade this all in over here. But just to show you, what if we chose negative 2x? Or negative 2, 0. So 0 for y, negative 2 for x. 2 times negative 2 is negative 4. Is 0 greater than negative 4? Yes. So that was an answer, which is why we shaded on its side. Okay? So that's the process we're going to do for all of these. Okay, so y-intercept of plus 1, slope of negative 3 over 1, so I go down 3 to the right one, down 3 to the right one, or up 3 to the left one. Okay, now there's no equal to, so once again, dashed line. Then I pick a test point. My favorite test point, we couldn't do it on question number 1, but my favorite test point is 0, 0. Because it just makes it a lot easier. So a 0 for y, a 0 for x, and then I simplify. Negative 3 times 0 is 0, 0 plus 1 is 1. Is 0 greater than 1? Nope. So I shade the other side. And that's all you do. Okay, next one. Plus 3, y-intercept of plus 3. Slope of negative x, that's like negative 1 over 1. So I go down 1 to the right one, down 1 to the right, down 1 to the right, and so on. Or up 1 and to the left. Okay, there's no equal to, so it's a dashed line. Pick my test point. I like 0, 0. 0 in for y, 0 in for x. Negative 0 is still 0. 0 plus 3 is 3. Is 0 less than 3? That is correct, so I shade on the same side of my point. If it were false, I would shade the opposite side. So hopefully you're getting the hang of this. Okay, y-intercept of negative 4. Go down to negative 4, slope of 1 over 4, so up 1 to the right 4, or down 1 to the left 4. Okay, now this one, notice that it has an equal to, so I draw a solid line here. Okay, now I pick my test point 0, 0, 0 in for y, and this is why I like choosing 0, 0, because I put a 0 in for x, my slope's an ugly fraction. But what do? I times it by 0. 1/4 times 0 is 0. 0 minus 4 is negative 4. Is 0 less than or equal to negative 4? No. So I shade the opposite side. Okay? Alright, now 3 and 6 and 7 are a little different, aren't they? Let's tackle 7 first. The thing you should notice with 7, there's no y value. If they only have one variable, go to that variable. The x-axis is the horizontal. We go to positive 4. It's going to be a vertical line. There's no equal to, so it's a dotted vertical line at x equals 4. Okay, it says x is greater. Greater is to the right for x, less than is to the left. It's greater, so I shade to the right. So that one's actually pretty simple, isn't it? Now, 5 and 6, there's two different ways you can attack these problems, okay? For 5, I'll use the first way. The first way is to take this inequality and to change it to be that slope-intercept form, that mx plus b. So to do that, I subtract 3x from both sides. That gives me y is greater than or equal to 5 minus 3x. Or I could rewrite it negative 3x plus 5. Regardless, my y-intercept is 5, my slope is negative 3. So y-intercept of 5, I go up to 5. Slope of negative 3, I go down 3 to the right 1. Down 3 to the right 1. Down 3 to the right 1. Okay? Now, it's got an equal to, so a solid line. Pick my test point 0, 0. I could use my new equation to figure it out, or I could use my old one. Doesn't matter. Either one works. So a test point is 0, 0. 0 for x. 0 for y. Simplify. 3 times 0 is 0. 0 plus 0 is 0. Is 0 greater than or equal to positive 5? Nope. So I shade right here. Okay? That's one way you can do those type of standard equations. The other way is like this. Okay? So, I can look at this and go, that's like 2x minus y equals 1. Let's think of it as an equation first. So, what if I want to find my x-intercept? Well, if you remember, x-intercepts always have a y value of 0. So let's get rid of our y. So I have 2x equals 1. And simplify. Divide by 2, we get x equals 1/2. So a 1/2, I have my x-intercept. Okay? Then, I say, okay, now I want my y-intercept. My y-intercept on the y-axis always has an x value of 0. So my x term I get rid of. So I have negative y equals 1. I divide by a negative. That becomes positive. I get y equals negative 1. So my y-intercept is at negative 1. Now, there's no equal to, so it's a dotted line. So using those 2 points, I graph it. Pick the test point 0, 0. And then, using my inequality now, not the equation, I put 0 in for x, 0 in for y. 0 minus 0 is 0. Is 0 less than 1? Yes, it is. So I shade the same side as my test point. Okay? And and we are good to go on that one. Okay, we already did number 7. So now let's take a look at 8, 9, and 10. So, number 8. So let's keep this space up here so we can draw our equations, our inequalities I should say. Okay, so Giselle runs a company that makes tablet computers. Each tablet requires an employee to assemble it and an employee to test it. There are 25 employees or fewer available, depending on who is out sick or on vacation. Write an inequality that represents the number of employees Giselle has available to do the work, and then graph the solution. Alright, so this one seems very difficult, but 25 employees or fewer, meaning she's got 25, so the number she has is less than or equal to that. So bx is less than or equal to 25. Okay, that's really all you have to do. So let's count by 5s. So that'd be 25. So it's x, so that makes us a solid line because it's equal to where x equals 25, and then less than, so we would shade to the left. Now technically we should probably say that 0 is less than or equal to x, because technically we wouldn't be over in the negatives because you can't have negative employees. But I mainly just wanted you guys to get that part done. Okay. So let's see. At Ben's greenhouse in early spring, there are many greenhouse plants to repot and many outside plants to water. If it takes Ben 5 minutes to repot each plant and 2 minutes to water each plant, and he has at most 2 hours before the greenhouse opens, what inequality represents the time Ben has to repot and water the plants before the greenhouse opens? What is the graph? Okay, so it takes him 5 minutes to repot, so let's call x repotting. The number of plants he has to repot, and 2 minutes to water, so we'll call y watering plants. Okay, so we go 5x plus 2y, and it says he has at most 2 hours, so it has to be less than or equal to 2. Okay, so with this one we can either turn it into the slope-intercept form to graph, or we can graph with the x and y intercepts. So let's try that one. Okay, so what I need to do is to find the y-intercept. I get rid of our x term, so we just have 2y is less than or equal to 2, divide by 2, and we get y is less than or equal to 1. So on our graph, y is a 1, I draw my first point. That's the y-intercept. Okay, then we cross out the y, so we have 5x is less than or equal to 2. For the x-intercept, we divide by 5, and x is less than or equal to 2/5, which 2/5 is about 0.4. So on the x-axis, I go almost halfway, draw my point. Now it's less than or equal to, so I draw a solid line going through those 2 points. Then I need to pick a test point. So why don't we pick the test point 2, 2. Okay, that one seems, because that 0, 0 is pretty close to our line. So I just want to make sure I'm far enough away that I don't have any mistakes. So our test point is 2, 2, 2 for x, so 5 times 2, plus 2 for y, 2 times 2. Is that less than or equal to 2? Well, that's 10, that's 4, we get 14. Is 14 less than or equal to 2? No, so we'd shade this way. Alright, and number 10 now. Okay, Toya is training for a triathlon and wants to bike and run on the same day. She has less than 3 hours to spend on her workouts, so we know it's going to be less than 3 hours, because it didn't say equal to, it just said less than. What inequality represents the time Toya has to bike and run? So let's call x biking, y running. So basically just the time biking and the time running, x plus y, would be less than 3. Okay, so let's turn this one into a slope-intercept form. So x plus y is less than 3. So to do that, we'd subtract the x from both sides. That would give us y is less than negative x plus 3. Hey, we already did that guy, didn't we? So we graph it. Y-intercept of 3, slope of negative 1 over 1x. So we go down 1 to the right 1. There's no equal to, so I know it's a dotted line. Pick our test point 0, 0. 0 for y, 0 for x. Negative 0 is still 0, plus 3 is 3. Is 0 less than 3? It is. So we'd shade this side. Though technically we'd probably say that only this would be the area that would matter, just because you can't go into negative running or negative biking. So within those would be the points that would work for the situation. Okay? Well, there we go, guys.